In this video, I will cover the imaginary unit I with exponents. So the definition of the imaginary unit I is that I is the square root of -1. That's why when we take the square root of -4, that is equal to the square root of -1 times the square root of 4. So that's why it's equal to 2i. I covered that in another video, but in this video, I'm going to do the imaginary unit with exponents so that you can figure out what I to any exponent is, like I to the 12th or I to the 50th. You'll know what that is equal to. So let's talk about the pattern. So I squared is equal to the square root of -1 squared, which is equal to -1. I to the third power is equal to I times I squared, which is I times -1, which is -I. I to the fourth is equal to I times I cubed, which equals I times -I, which equals -I squared. And we have to keep simplifying that. So we know that I squared is -1. So this is a negative times -1, which is a +1. I to the fifth is equal to I times I to the fourth. We know that I to the fourth is 1 from above, so that's equal to I. I to the sixth would be I times I to the fifth. From above, we know I to the fifth is I, so this is I squared, which from above we know is -1. I to the seventh is equal to I times I to the sixth, and I to the sixth from above we know is -1, so this is equal to -I. I to the eighth is equal to I times I to the seventh, so this is equal to -I. Again, we have -I squared, so we know that's negative times -1, so that's a +1. Now hopefully you're seeing the pattern here. I, -1, -I, +1, I, -1, -I, +1. And if we kept going with this, we would continue this pattern. We can write it as a circle since it keeps going in this circular motion. This is I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth. So this would be I to the ninth. So let's write that down so you can really see the pattern. I to the first is I to the second would simplify to -1, I to the third would simplify to -I to the fourth simplifies to 1. I to the fifth simplifies to I to the sixth simplifies to -1, I to the seventh simplifies to I to the eighth would also simplify to 1. Let's do one more round. So this is I to the ninth, I to the 10th, I to the 11th, and I to the 12th would simplify to 1. Since this pattern repeats in multiples of 4, you can divide your exponent by 4, and the remainder will tell you where it ends. So if we're looking at I to the 5th, so we know that it would go around 1 full time and then have a remainder of 1, which ends it up here. If we took I to the 10th, if we divided 10 by 4, that would mean that we would go around 2 full circles, and then we would have a remainder of 1, 2. And that's why we end up here for I to the 10th. A way to remember the pattern of the circle is I1, negatives in the middle. So it's going in this direction, And this one is if you have a remainder of 1, because that's what I to the first is. And this is if you have a remainder of 2, because this is what I squared is equal to. This is what is equal to negative I if you get a remainder of 3 after you divide by 4. Then your answer will be negative I. And finally, you would have your answer would be 1 if you get a remainder of 0. So let's look at an example. If we needed to simplify I to the 50th power, then we would divide 50 by 4 and see what our remainder is. So we'll use long division here. So 4 goes into 5 one time, subtract, bring down the 0, 4 goes into 10 twice, and we have a remainder of 2. So that means that I to the 50th is equal to negative 1. It would mean that we would go around the circle 12 times, and then we would end up here and then here for a remainder of 2. So we would say that I to the 50th is equal to negative 1. If we wanted to evaluate I to the 101, we would divide 101 by 4. So 4 goes into 10 2 times. Bring down the 1. 4 goes into 21 5 times. And now we have a remainder of 1. So since we have a remainder of 1, I to the 101st power is equal to I. For our next example, let's do I to the 43rd power. If we divide 43 by 4, then we would have a remainder of 3. Since we have a remainder of 3, I to the 43rd power is equal to negative I. For our last example, let's do I to the 80th power. So you can see that 80 is divisible by 4, but if you don't see that, you can always go ahead and do the long division. So 4 goes into 80 20 times. So I to the 80th power, since there's a remainder of 0, would be equal to 1. I hope you've enjoyed this video. Please like, subscribe, and comment, and check out my other videos.